I started the recording, everybody. Hopefully today is the last class for Redox and we are done with this chapter. See, I told you all the other chapters are 2 to 3 classes to an extent. After this, the chapter number 4 is pretty lengthy. Then chapter 5, 6, 7, just 3 classes, 4 classes, that's it. And then 8 is small, 9 is 2 classes, and then we'll move on to organic chemistry because half of your syllabus is organic chemistry. So we'll be done with 50% of your syllabus, inshallah, within the next month or so. Tomorrow's lecture के कितने pages छोड़ दें? Leave about, depending on your handwriting, if it's middle handwriting, leave about 5 to 6 pages. That's it. 5 to 6 pages max. That's it. It was a pretty short lecture. 5 to 6 pages, then leave 4 pages. If your handwriting is medium, then leave 4 pages. I'm talking about double pages. So by 4 pages, I mean 1 page and the other page, both sides. That's it. So 4 pages does not mean you leave 4 full pages. Then that becomes 8, I guess, if I'm not wrong, right? So yes, pretty simple, pretty easy. We did just disproportionation reaction, which is a type of redox reaction in which both reduction and oxidation takes place simultaneously, but it's a type of redox reaction in which an element in a single species is both oxidized and reduced simultaneously, and you will learn that. It's pretty simple, it's not a big deal, but there's a common misconception among students which I clarified in the last class, and it comes a lot of the times in MCQs. That's why teachers think MCQs are difficult, students think their MCQs are difficult, but in reality, their concepts are weak. That's the only reality behind MCQs looking difficult. If your concepts are strong, after chapter number 4, we will start off with MCQs, and you will see you'll be able to breeze through them, provided you've taken the classes, made notes, and your concepts are crystal clear because of that, right? Acha. Today what we are going to cover is the last subtopic of redox, which is simple half equations and complex half equations. Simple half equations and complex half equation. Complex half equations, right? Now, complex half equations are very important, but in our course, it's just acidic conditions. Complex half equations in acidic conditions. What do we mean by that? We'll look into that in a while. But first, let's talk about simple half equations. What are half equations? Half equations show individual gains and losses of electrons, like we've done previously, and in the previous classes, I've also shown you some half equations. You know how to go from a full equation into half equation. Like, for example, magnesium reacts with half oxygen to give you MgO, right? It's a brilliant white flame. You might have seen Harry Potter. Have you not? Have you seen Harry Potter? It's that Expelliarmus, it's that luminous, that light in Harry Potter is basically this particular reaction that's taking place. It's so beautiful. Chemistry is such a beautiful science. It's used in so many places. Now, this is the full equation. But if I were to break it down into 2 half equations, how can I do this? Well, I'm going to look at magnesium. Magnesium is going from Mg to Mg2 plus, sir. But this is not Mg2 plus. It is still Mg. No. Please, this is O-level conceptual confusions that you have. This is the formula MgO, but it's an ionic compound. Ionic compound means that if you zoom into it, it is basically the Mg2 plus ion and the oxide minus ion, 2 minus ion, and they're just, that's just the formula for it. They are held by electrostatic force of attraction. These are oppositely charged ions. It's an ionic compound. So this is just the formula for it. That doesn't mean it does not have charges. It absolutely does have charges, right? So if you won't go from magnesium to Mg2 plus, that's the first half equation, magnesium going into Mg2 plus, and here the half O2, which is oxygen effectively, going into O2 minus. That's it. Now, let's write the gains and losses of electrons. I know magnesium going into a magnesium 2 plus is only possible that if it loses 2 electrons, and loss of electrons conventionally is written on the right hand side with a positive sign. And I've taught you guys many other ways to do that, right? Similarly here, a single oxygen is going into O2 minus, right? It's just a single oxygen because I've halved it. So it's not O2 anymore, it's just O. So O going into O2 minus, how does it do that? It does that by the gain of 2 electrons. And you guys can see that right here. The gain of 2 electrons is conventionally written on the left hand side of the equation with a positive sign, right? And if I add these 2 equations together, that's how my full equation forms. So the loss of electrons must be equal to the gain of electrons, and so therefore magnesium, you just add the left and right hand side once the loss and gain are equal. So Mg reacts with half O2. I've summed up the left hand side why didn't you sum up the electrons? Because the gain and loss of the electrons are equal, right? So you could say they cancel out on both sides, right? And then it goes into Mg2 plus, sorry, it goes into Mg2 plus and O2 minus. And Mg2 plus and O2 minus is obviously an ionic compound, so I'll write the formula for it, MgO. And see, this is how full equations in fact are formed. So how are full equations formed? They are formed from two half equations, right? It's pretty simple, pretty logical, pretty straightforward, no rocket science here. No rocket science. We've been doing this in the last couple of classes. We have been doing this in the, in O levels and IGCSE as well, right? Next. Now, what if I give you another example? Let's suppose zinc reacting with maybe copper sulfate. You've seen such reactions in O levels and IGCSE where zinc is the more reactive metal. So the more reactive metal will displace the less reactive metal from its salt solution. Remember the displacement reactions. So what happens is zinc is going to displace copper. What should be the formula? Zinc is 2 plus, SO4 is 2 minus. This is going to give you ZnSO4. That's the formula that I'm going to write. That's the ionic compound which forms. And copper, which has been displaced, is going to come right here. We don't need to know these reactions for A levels. You'll study them later on. But this is just a recap. In O levels, if you study this, you should know this. You should have studied this in O levels, these displacement reactions, right? So this is what happens. Now, what if I want you guys to convert this into half equations? How do you convert this into half equations? Again, individual gains and losses of electrons, right? So zinc is going into zinc 2 plus. That's the individual loss of electrons. What about copper? Copper is going from copper 2 plus to copper, right? It's copper 2 sulfate, copper 2 sulfate. I have to, whenever I write the name for copper sulfate, I won't say it's copper sulfate. I won't get any mark. It's copper 2 sulfate because we know copper has variable oxidation numbers. It can be copper 1 sulfate or copper 2 sulfate. How do I know it's copper 2 sulfate? Because the formula is CuSO4. And the only reason why the formula could be CuSO4 is if the 2 minus equals 2 plus. That's why the formula is CuSO4. It would be Cu2SO4 if it was copper 1 sulfate. Ain't that true, right? So that's the idea. Now, this is what has formed. Now, individual gains and losses of electrons. Zinc goes from zinc to zinc 2 plus. Great stuff. And copper 2 plus. It's copper 2 plus right here. See, it's in the form of its ion. It's copper 2 sulfate aqueous. So it's copper 2 plus ions going into solid copper. So going into copper. Sir, what about the sulfate? That's the question you should ask me. What about the sulfate? Sir, sulfate, as we learned in our O levels and IGCSE and even in yesterday's class, is the spectator ion. So spectator ion are not written. Spectator, Harvey Specter, spectator ion. Spectator ions are not written in these half equations, right? Spectator ions are those ions which do not take part in the reaction. See, SO4 is SO4 2 minus on the left hand side, and this entire unit is SO4 2 minus on the right hand side. So they don't take part in the reaction. They are present in the reaction. Once an MCQ came and it said spectator ions are present in the reaction, student did not select it. Why? Why? They are present in the reaction. That's true. They are present in the reaction, but they don't take part in the reaction. That's a difference, yeah? Being present is something like you guys are present in this class, all of you guys are present in this class, but somebody is maybe, eating food and watching Netflix simultaneously. So they are present, but they're not taking part of, they're not a part of this class. They're not taking part in this reaction, right? In this beautiful reaction. So we don't write spectatorize. Now, so zinc has gone from zinc to zinc 2 plus, great stuff, and copper 2 plus has gone from copper 2 plus to copper, right? How do we do that? Zinc goes into zinc 2 plus by losing 2 electrons, and copper 2 plus gains 2 electrons to become copper. These are two half equations, and if I want to write the full ionic equation for it, see, the full ionic equations, two half equations combine, and I can end up with a full ionic equation. So the 2 electrons and 2 electrons are cut at the left and right hand side. Zinc actually reacted with copper 2 plus ions, and what it did was it took this copper 2 plus ions, it displaced this copper 2 plus ions to give you copper, and it itself became the zinc 2 plus ion. And obviously this positive ions must have a negative ion, and those were your sulfate ions, but because they are spectator ions, we don't even write them in our ionic reaction, right, or ionic equation. Ionic equations are equations in which we do not include the spectator ion, right? Similar is the case right here. I'm giving you guys simple half equations, making simple half equations, right? For example, I have like two bromide ions, And like they react with chlorine, and this is going to give you chloride ions, two chloride ions and bromine. And see, you guys must be confused from your O levels, but it's time to finish those confusions. Which confusions am I talking to you guys? Which confusions am I talking about to you guys? Which confusions, guys? The confusions that you guys are scared of these negative ions. Oh, this is a negative ions reacting with chlorine. How this? Please understand that this negative ion does not exist alone in this universe. It must have a positive ion. This must have a positive ion. This must have a positive ion. But please understand that those ions are spectator ions. You can add it. This maybe was potassium bromide or sodium bromide, and this is now potassium bromide or potassium chloride or sodium chloride. So it's time to finish those confusions. If you have a negative ion, that means there's a positive ion here, there's a positive ion here, but in the ionic equation, this is just a full ionic equation. I have not written that positive ion. If you wanted, you could have said, hey, you might be used to this stuff. KBr reacting with chlorine. Chlorine is more reactive than bromine, therefore it displaces it, gives you KCl plus Br2. You must be used to this, but if you understand, it's basically the bromide ion, which is being displaced by Cl2 right here, and then you get chloride ions and Br2. This potassium ion and this potassium ions are spectator ions. So it's please important that these negative and positive ions, they must have their counterpart with them, but since they don't take part in the reaction, we don't write them. Open your brainerinos. Okay, so I'm gonna erase this stuff. I'm gonna erase this useless, pathetic, because it's the ionic equation which is actually telling you what is taking part in the reaction. The actual reaction is the ionic equation, not the full equation, everybody. And I'm gonna kill a mosquito. Please come. Oh no, it ran away. Okay, kidhar se aa jate. Khair, how do I convert it into two half equations? Again, bromide ions, bromine, chlorine, chloride ions. So bromide ions 2Br minus go into Br2, and chlorines go into Cl minus 2 chloride ions, right? Great stuff. Now, how do I balance it out? We know that you have overall, please understand, you had two bromide ions, right? So two bromide ions means you have Br1 minus and Br1 minus. And when it became Br2, how many electrons are lost in total? Obviously 2 electrons, not 1 but 2. Why? Because each bromide ion loses 1 electron, right? So since you have 2 bromide ions, in total 2 electrons are lost. And you guys can even use the mathematical version of it, that the overall charge here is -2. The overall charge right here is -2, and here the overall charge is 0. So how do you make -2 equal to 0? By adding 2 electrons, because when you add 2 electrons, each electron is -1. So 0 minus 2 is -2, in fact. So -2 equals -2. But please note that this does not in any way, shape or form mean that the Br1 minus has the oxidation number of -2. No sirree. This means that the bromide ion still has the oxidation number of -1. I'm just considering the overall charges to balance out this equation, please. So we can consider the overall charges to balance out the equation, or the overall charges to get to the proof that the overall charge on a compound is 0. Then we talk about all the charges, right? So if you want to balance the equation, you have to consider the overall charges on left and right hand side. But this in turn never ever in any way, shape or form means that bromide ion has an oxidation number of -2. No, it's still -1. I'm just considering 2 bromide ions, so each has -1. I'm just adding them because in totality on the left side there are -1 and -1, so -2, and here you have 0. So how do I make -2 equal to 0? By adding 2 electrons. Great stuff. That's my first half equation. Cl2 goes into Cl2 chloride ions. So what does that mean? That means you need how many electrons? Chlorine must have gained 2 electrons, right? But no, not each chlorine. In totality, each chlorine took 1 electron. Each chlorine took 1 electron, right? It's like this. If I show it to you, each chlorine takes 1 electron, and that's how 2 chloride ions form, right? So these are 2 half equations, and when you add these half equations together, you are going to end up with a full ionic equation, right? So this is simple half equations, and you've been learning to do this since O levels and IGCSE. If you've not been taught this, well, now you know. It's not rocket science. Pretty simple, straightforward, easy. Let's talk about complex half equations for a moment, right? Let me give you a full ionic equation. Cr2O7 2-. This is the dichromate ion. This is aqueous. And again, this Could this dichromate ion is bonded to some sort of positive ion. It can be potassium dichromate, sodium dichromate. We don't care about that ion because obviously that must have been the spectator ion. Let me give you a full ionic equation. Ionic equation, right? This is how it looks like. And now things are going to start to look a little spicy and a little fun as well. You'll be masters of it by the end of this class. Masters. Oh, oh my God, sir, what have you written? Oh, well, it's time to see that. Basically, what happens is, look at how can I convert these into half equations. First of all, let's look at the simple bit of it. I know you have 6 iron ions here and 6 iron 3 plus ions here, right? 6 iron ions, 6 iron 3 plus ions. So I know one half equation should look something like this. It must be 6 iron 2 plus ions going into 6 iron 3 plus ions. But we know that the charges on left and right hand side aren't balanced. Here the overall charge is what? 6 times 2, that's plus 12. The overall charge is plus 12 here. Does that mean that iron's oxidation number is plus 12? No, iron is still plus 2. I'm talking about the overall charge because there are so many 6 plus 2s. Plus 2, plus 2, plus 2, plus 2, plus 2. So the overall charge is plus 12. And 6 times 3, the overall charge here is plus 18. How do I make plus 12 equal to plus 18, sir? How do I make plus 12 equal to plus 18? Well, I know. How do I make it equal? How do I make it equal? How do I make it equal? I know I can, from plus 12 to plus 18, it means there's a loss of electrons. And we write the loss of electrons on the right hand side with a positive sign. That's the conventional way. So how many electrons must be lost? 6 electrons, because 18 may, you minus 6, you get 12, right? Or you could have said, hey, each Fe2 plus loses 1 electron. Each Fe2 plus loses 1 electron to go into Fe3 plus. So 1 electron, 2 electron, 3, 4, 5, 6, because you have 6 Fe2 plus. So you can do it mathematically or logically. And then the second half equation is whatever is left behind. That's the second half equation. This stuff on the left and this stuff on the right. That's the second half equation for you, right? So it's Cr2O7 2 minus plus 14H pluses gives me 2Cr3 plus 7H2O, right? That is what's left behind. And now you just need to balance the electrons. Please understand, whenever we were to form half equations, we need to balance it with electrons to make the charges on both left and right equal. So here you see that you have a 2 minus charge, and here you have a total of 14 plus charge, right? So it's minus 2 and plus 14. What would the charge be equal to? It would be plus 12, sir. And what is the charge equal to here? It's just plus 6. H2O has an overall charge of 0. Right? So plus 12 equal to plus 6. How do I do that? Plus 12 equal to plus 6. How do I do that? How do I make 12 equal to 6? Well, I add 6 electrons here. You know, by adding 6 electrons, I'm just subtracting 6 from 12, right? So when I subtract 6 from 12, I get 6, right? And you'll realize that the 6 electrons lost by Fe2 plus are the 6 electrons that have been gained by the dichromate ion, right? Now the question is, this was already done for you. This was already done for you. Now the electrons lost and gained are equal. You can add these two half equations together and you would end up with this fella right here. But the real question is, you knew this stuff. You also knew this left-hand side and this left-hand side. You just needed to balance the electrons in both cases. The question is, how did you know that this hand side equates to this hand side? How did you know that this is the equation? How did you know that it would have 14 hydrogen ions? How did you know it would have 7H2O? How did you know this? How did you know this? How did you know all of this? This is where we come into the complex ion half equation. So you need to know how to make them. This will never be given to you in the exam like so. No, then what's the point of the exam? You know, if they give it to you like this, you just need to take this out and take this out and add 6 electrons here and here and you're done. You know, it would be pretty simple, and it's still very simple. It's not that complicated, but please understand that if it was just like this, it would be a piece of cake. You just needed to add electrons and that's it. No, you need to be able to decipher the entire half equation. And see, here oxidation has taken place and here reduction has taken place because there's a gain of electrons. So it is in fact a redox reaction. So it is in fact a redox reaction. But how did you come up with this reduction half equation? Let's talk about that for a moment, right? Let's talk about it. Basically, what happens is, let's talk about this dichromate ion going into the chromium ion, right? So Cr2O7 2 minus going into the Cr3 plus ion. I will make this, we know that this is the reality. It's the dichromate ion going into the Cr3 plus ion. Where is this hydrogens coming from? Where is this H2O coming from? In a moment, right? But this is the reality behind it. It is Cr2O7 2 minus going into Cr3 plus, right? Why didn't you take dichromate and H separately? Adil, you'll understand it in a moment, right? You'll understand it just in a moment, Now, what do we do? The way you balance these complex half equations is, and please understand, we have acidic solutions. It's complex half equation in acidic solutions. Because in our course, we only have acidic solutions, not basic. Basic is not difficult, it's just one extra step. Basic is not difficult, one extra step, but first let's, master acidic solutions, and if you want, I will even teach you, I will also teach you the basic solution balancing, later on, probably. Khair. Acidic solution means what? What do we mean by acidic solutions? That there would be hydrogen ions. Remember in O-levels and IGCSE, whenever you used to take potassium manganate, or you used to take potassium dichromate, which in fact is this fella right here, which I've written in the equation, we used to write /H plus. What did we use to call it? We used to call it acidified aqueous potassium manganate. It is acidified aqueous potassium dichromate. And students used to ask, sir, why is it acidic? What's the purpose of it? Now you'll understand the purpose of it, right? So how do we balance this equation out? How do we balance it out? The first step is to balance all the atoms except for H's and O's on the left and right hand side, right? So balance all atoms on left and right except H's and O's. Everything would make sense in the end. Just follow my lead, right? So balance all the atoms. Let's look at it. I don't need to talk about O's or H's because it says except O's and H's, right? So O's and H's left behind, balance all the atoms. How do you balance it? You have 2 CRs on the left and you only have 1 CR on the right. So what do? The first step, balance all the atoms. I'll write it again. You had the dichromate ion right here, and now it is 2 CRs, because here you have 2 CRs, here you must also have 2 CRs. So I've balanced all the atoms except H's and O's. I can't even see H's right here. Now, the second idea is just step-by-step approach of solving these complex half equations, right? Step-by-step approach. Then what do we do? Well, you need to understand that it's an acidic solution, right? It is an acidic. I'm going to give you the concept behind it and then I'll teach you what to do. But please understand that it is an acidic solution. And what do we mean by acidic solution? Acidic solution means that there are hydrogen ions, aren't they? There are hydrogen ions in this solution. There are hydrogen ions. I've added hydrogen ions, good stuff. Now, what would these hydrogen ions do? These hydrogen ions will start to pluck these oxygens. They will start to pluck these oxygen. Puck. They will start to pluck. O, come. O. And these hydrogen ions will be, plucking O, pluck another 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 O. And they will start to form H2O, because H's and O's, 2 hydrogen ions and 1 O will give you H2O. 2 hydrogen ions and 1 O will give you H2O. 2 hydrogen ions and 1 O will give you H2O. So how many H2Os are you going to actually form? Because you have 7 O's, how many H2Os will form? Obviously 7 H2Os, because every time each O is plucked by 2 hydrogen ions, you're going to have H2O, right? So what are we going to end up with? Sir, we are going to end up with 7 H2O. So I'll write this right here, Cr2O7 2 minus, and that's going to give me 2 Cr3 plus 7 H2Os, right? And that's why the second step for it is always to write down balance oxygens, or write balance oxygens with H2O on deficient side. And the idea behind it is the one that I've taught you, right? The idea behind it is the one that I've taught you, but what we do is you can simply learn this step. You don't need to know this idea. You just can simply learn this step that, you balance out the O's. You have 7 O's here. So how many H2O's will I balance it out with? With 7 H2O's. So the number of O's that you have will be the number of H2O's on the opposite side, right? So if you have 7 O's here, you did not have 7 O's here. So I balanced out the O's with H2O's on the deficient side, on the more deficient side. Here you have 7 O's, here you have 0 O's. So how will I balance these O's? With H2O's. That's it. The idea behind it is the same. You have hydrogen ion, hydrogen ion, hydrogen ion, hydrogen ion, whatever, right? Now the question is, the next step is balance out the hydrogens. Balance the hydrogens with H plus ions on deficient side. So now you'll see that how many hydrogens do you have? You have 7 times 2. You have 14 hydrogens. You have 14 hydrogens. So how can I balance 14 hydrogens? So I will balance these 14 hydrogens with 14 hydrogen ions. So Cr2O27 minus plus 14 hydrogen ions gives me 2Cr3 plus 7H2O. Right? Great stuff. And now, if you want to use the logic behind it, what was the logic? The logic was they will come here, O's, H2O, O, H2O. How many H plus ions do you need to make one H2O? How many H plus ion do you need to make one H2O? Come on, you guys tell me. I will give you the logic as well as the steps. So, how many H plus ions do you need to make one H2O? You need 2 H plus ions. So, if you were to make 7 H2Os, how many H plus ions would you need? If you were to make 7 H2Os, how many H plus ions would you need? Everybody's correct. They're saying 14, and that's what I've done. 14 H plus ions to make 7 H2O. See, if you do it with logic, you can do it with logic, but I will never recommend logic, because students sometimes get confused in logic. So this is the idea behind it. You need to know the logic because obviously I teach concepts, not rote learning, but then in A levels, because questions get tricky, that's why even scientists at PhD level follow these steps one by one. Right? So now everything is done. Everything is balanced out except the charges, right? Everything is balanced out except the charges. And how do you balance out the charge? So the fourth step is balance the charge with electrons, right? So what is the overall charge here? This is minus 2 and this is plus 14. So overall charge here is plus 12, and here 2 times 3, the overall charge is plus 6. Does that mean that the oxidation number is plus 6? No, oxidation is plus 3. Hydrogen oxidation is plus 1. In this, chromium's oxidation number is what? Plus 6, I believe. You can calculate it. But this is, I'm talking about the overall charges on the left and right hand side, adding everything together. So 12 plus and plus 6. What do I do to it? How do I go from plus 12 to plus 6? By adding 6 electrons. And see, you'll notice this fella right here. That is the reason why in the half equation, see, that's the reason why in the half equation I took hydrogen ions and water as well, because I realized that it pertains to this complex ion. It pertains to this complex, because a lot of students started asking, sir, why aren't you writing this separately and that separately? Because this hydrogen ions, this H2O, this Cr3 plus ion, this they all belonged to this fella right here. So all of this, and I took the iron separately and these fellas separately. That's it. That's how you need to make equations. This is how you need to make complex half ionic equations for these complex ions, obviously. Let me give you the example again. It's your turn to do it now. Cr2O2 minus, right? And then it reacts with Fe2 plus, and I know that Cr2O7 minus is what? Or O72 minus is a reducing agent. It's an oxidizing agent, my bad. It's an oxidizing agent. So what is it going to do? It is going to oxidize iron 2 plus to what? It's going to oxidize iron 2 plus to iron 3 plus. I should know this. Even if the examiner just gives me this much information, I should be able to decipher stuff. I should be able to say, hey, this is an oxidizing agent. Potassium dichromate. You knew that this is an oxidizing agent. Changes color from orange to green, right? You know this. So this is basically the oxidizing agent, and what would it do? It will oxidize this iron 2 plus to iron 3 plus. I know iron can be oxidized to from 2 plus to 3 plus, not further, right? So 2 plus to 3 plus, good stuff. So how can you write the full ionic equation for it? I want you guys to try it on your own. Treat iron separately, treat dichromate separately. Don't rote learn stuff. Start solving it slowly and gradually. You'll end up with the full ionic equation. I'll give you 1 minute and then I'll solve it. Try it. Even if you can't do it right now, it's fine. Just try it. Manur has such a beautiful question. Sir, where are these 6 electrons coming from? Manur, they are coming from somewhere you'll see right now. When you start solving this, you'll understand where they are coming from. Right? Beautiful question, Manur. 500 rupees inam. 500 rupees from my side. Send me your Easy Paisa or bank account. I will send it to you right away. Now you know, Raima. Now you know what belongs together and what belongs separately. Iron ions are not complex. These are complex half equations, like in which you have dichromate ions. These are called polyatomic ions, complex ions, polyatomic ions, radical ions. You've been studying them from O levels and IGCSE. So I hope you know this. Come on, shabash. Do it. Shabash. And these are all acidic conditions, not basic. Acidic conditions. Basic, I will teach it to you at the end if you want to know. Because those basic conditions are going to help us not rote learn chapter number 4. In chapter number 4, you will learn certain reactions. And these basic conditions will help you realize and understand those reactions rather than rote learning them. And students cry in chapter number 4 because there's so much rote learning. But we are going to make rote learning a piece of cake by understanding the reality, the real underlying reason behind every single reaction. So chapter number 4, that's why it's pretty pathetic for students. But inshallah, you'll enjoy it. I promise. Chalo, full ionic equation. And let me just tell you that this Cr2O7 2 minus goes into Cr3 plus. I forgot to tell you this. Goes into the chromium ion. You should know this. Slowly and gradually you will realize that the dichromate, once it undergoes reduction, because it's an oxidizing agent, so it will reduce itself to oxidize iron 2 plus. And obviously once it reduces itself, it goes from +6 to +3. So slowly and gradually you'll start to even know this. But this is what I'm telling you. Write the full ionic equation between the reaction of iron 2 plus and dichromate ion. This is oxidizing agent, this is a reducing agent. We know oxidizing agents and reducing agents would react together. Yes, sir. Yes, go. Let's go. Let me do it now. Okay, so I know you had a dichromate ion, and I know it goes into the Cr3 plus ion. Always a dichromate ion goes into the Cr3 plus ions once it is reduced. It goes from +6 to +3. It is reduced itself and therefore is an oxidizing agent because it oxidizes iron. What does it oxidize iron to? It oxidizes iron from Fe2 plus to obviously Fe3 plus. Fe3 plus, the state in which, the oxidation state in which, iron also undergoes rusting. Great stuff. Khair. So this is the initial step. Now, what am I going to do? Let's start balancing our complex equation, half equation. This is my half equation 1. This is my half equation 2. So let's start balancing it. Well, you had, the first step was to balance all the atoms except for H's and O's. So here you have 2 Crs. I'll add 2 Crs here. Great. The next step was to add H2Os, balance the oxygens with the number of H2Os on the deficient side. So you have 7 oxygens here. What do? I will balance it out with 7 H2Os. Great stuff. Easy peasy, huh? The next step, you need to balance out these hydrogens. 7 into 2, 14 hydrogens on the right. How many hydrogen ions do you need? With hydrogen ions, obviously. So I need 14 hydrogen ions. Great stuff. And the reality, now you know, why do you need 14 hydrogen ions? If you want to logically think about it, it's acidic conditions. Please, even if I don't write it, even if the examiner doesn't write it, it's acidic conditions, right? So in acidic conditions, you have H plus ions. These H plus ion, take these O's, gives you 7 H2O. How many H pluses are needed for each O? 2. So 7 H2Os, if they are being formed, 7 O's are going into 7 H2Os, then therefore you need twice the number of hydrogen ions. So 14 hydrogen ions. That's it. And then in the end, balance the electrons. Here you have plus 12 overall charge. Here you have plus 6 overall charge. How do you go from plus 12 to plus 6? By adding 6 electrons. Teachers butcher this concept. Pretty simple, right? Now, the next question is Manur's question. Coming to Manur's question. Manur said, sir, we know that these are 6 electrons right here, right? And what is the half equation from iron going into, from iron 2 plus to iron 3 plus? How does iron go from iron 2 plus to iron 3 plus? Obviously by losing 1 electron. Now, if I want to write the full equation, Manur, what do I say? I say that the electrons gained must be equal to the electrons lost. Right, Mahnur? It's not possible that these 6 electrons come out of thin air. No, 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 no. How is iron only losing 1, but the dichromate is gaining 6? That's not possible. That's why we say electrons lost must be equal to electrons gained. That's the entire idea of redox reactions. So electrons lost cannot be 1. They see here you have 1 electron, but gain is 6. That's not possible. You need to make these electrons equal. How are they equal? Sir, you multiply 1 here, obviously, and multiply by 1 doesn't make a difference. You multiply 1 here, and you have 6 electrons at the top, so you multiply it with 6 here. Why are we doing this? Remember, in O levels, you used to rote learn this, that you need to balance electrons. Why are you balancing electrons? Now you know why you're doing it, Manur. You know, kiddo, you know that the electrons gained must be equal to the electrons. How is it possible that dichromate is gaining 6 electrons, but iron is only losing 1 electron? It's not possible. We just make our life easy, right? So once I multiply this with 6, what do I end up with? I end up with 6 Fe2 plus, giving you 6 Fe3 plus 6 electrons. Now we can add this uno and tres. 1 and 3. Now I'm going to add this. Why? Because see, 6 electron lost are equal to 6 electrons gained. And if you were to just if you were just asked by the examiner to write the half equation, even to this extent it's correct. But if you want to go from 2 half equations into the full ionic equation, then you need to make sure that electrons gains and losses are equal, right? So what do we do? Now just add the left hand side to the left hand side, and the right hand side to the right hand side. Why am I ignoring electrons? Because electrons gained are now equal to the electrons lost. Cancel out, right? So Cr2O7 2 minus plus 14 hydrogen ions plus 6 Fe2 plus gives you 2 Cr3 plus 7 H2O plus 6 Fe3 plus. That's it. And see, Sir Suleiman wrote the same thing initially. It doesn't really matter if you switch their positions. Doesn't really matter. This is what I wrote. So how did I knew this was the equation? Because I knew my chemistry. That's it. That's how you balance out. That's how you balance out complex half equations. That's how you do it, right? So the entire idea is to get these balancing numbers. What will the examiner do? What can the examiner do? That's the first thing the examiner can do, give you something like that. The second thing the examiner can do is pretty beautiful. It's Cr2O7 2 minus plus he will mess with you. Right? R dash plus dash. How do you solve this? He's saying blank, 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 blank. How do you solve this? How do you know the balancing numbers? So you split them into 2 half equations. That's it. You split them into 2 half equations. You know that this dichromate ion goes into chromium. Great. And this hydrogens is because of this stuff. And this H2O is because of this stuff, right? So I'm going to ignore hydrogens and H2O. I will get the figure from balancing this to this, right? And then you just go from Fe2 plus to Fe3 plus, right? So let's do the easier one first. Fe2 plus going from Fe2 plus to Fe3 plus. And how do we do that? By loss of an electron. Done. That's the first step. Done. Then Cr2O7 2 minus going into Cr3 plus. First of all, balance all the atoms except for H's and O's. 2 Crs, great. Next, balance because they are acidic conditions all. See, and even if the examiner doesn't mention it, you see hydrogen ions here. So these are acidic conditions. So in acidic conditions, what happens? So the H plus ions will pluck the oxygens and gives you H2Os, right? But that's the logical way of thinking. We will not use logical way. We will just stick to our steps. If you ever forget, recall your logics, right? But these O's are gonna, you have 7 O's, balance out the O's with H2Os because that's quicker, In exams, you can't be saying, oh, this H plus will pluck. No. We don't have that much time. Done. And now you have 14 H pluses, 14 hydrogens, so balance those hydrogens with H pluses. And now in the end, balance out the electrons. You have plus 12 here, plus 6 here, right here, plus 12 and plus 6. How do you go from plus 12 to plus 6? By adding 6 electrons, right? Because plus 12 plus 6 electrons gives you plus 6, and this is plus 6 in totality. So this is the balanced equation. Now the next step is add these two equations. Now you know that the electrons gained must be equal to the electrons lost. So what will I do? I will multiply this fella with a 6 serino. So what do I get? Let's add them. So in totality, now you have what? I'll just, instead of multiplying with 6, I'll just multiply it with 6 directly. So this becomes 6, this becomes 6, this becomes 6 to make the electrons gained and lost equal. 6 cuts out with 6. You have 6 Fe2 plus, or let's write it in the examiner's way, chromate ion plus 14H plus ions plus 6 Fe2 plus ions at the left hand side. Pretty simple, huh? And then at the right hand side, 6 Fe3 plus 2 Cr3 plus 7 H2O. Here you go, examiner. Examiner said, what is H plus? So that's 14. What is Fe2 plus? That's 6. What is this 2? What is this 3 plus? That's 6. What is this H2O? That's 7. That's it. And you'll see everything is balanced. You can even check it out. All the atoms on left and right hand side, inclusive of the charges, are balanced, right? So let me write the steps again. What did we actually do? The first step is balance all atoms except H's and O's. Next, in this case, we balance the Cr first, right? The next step is to add H2O where oxygen deficient, where O deficient. Balance the O with H2O. Let me make it easy. Balance O with H2O on the deficient side. Right? Balance hydrogen of H2O with H plus ions. Add electrons. And obviously there are different methods to balancing this equation. This is one way. The next way we will learn, inshallah, hopefully in today's class, if not in tomorrow's class. Probably I'll take it to tomorrow, because this in it itself is a beautiful concept. So I will teach you guys how to balance this equation without going into this much detail, although you need to know this. I will teach you the shortcut of balancing this. A lot of teachers don't. I will teach you the shortcut of balancing this, but you need to know how to come up with these equations. They are tested a lot of the times in your exam. I will teach you the shortcut for it. Sir, steps थोड़े दिखाइएगा. Steps, ये लो. I'm doing the steps. So add electrons with a plus sign. If you want to even further solidify this step, with a plus sign to the more positive sign, to the more positive side, if you want. Positive side. See, if your concepts are clear, you can add whatever steps for yourself. The more positive. See, this was plus 12 and this was plus 6, so I added 6 electrons to the more positive side. You know, yeah. Balance O with H2O on oxygen deficient side. On H deficient side. Done? Now, next. Let's do a couple of more examples. Sir, how did we get 6 and 12 on each side? Please explain. I would have explained, but you left the class. इतना टेंशन ही ना बने यार, जिंदगी सेट हो जाएगी. Done? Easy? Okay, next. Br2. Question. Br2 going into HBr. What do we do? How do you balance this equation? Again, acidic conditions. Balance this half equation. Acidic conditions. How do you do that? Well, again, balance out all the atoms except the H's and the O's. So you have 2 Brs, you only have 1 Br here. So let's balance out the Br. 2. Done? Next step. Add H2Os on the side where oxygen is deficient to balance the O's, right? Are there any O's here? No. Let's move on to the next step. Balance out the hydrogens with the hydrogen ions on the more deficient side. So you have 2 hydrogens here. What do I do? Hanji, you have 2 hydrogens on the right. How do I balance these 2 hydrogens on the right? Add 2 hydrogen ions on the deficient side. That's it. Next, balance out the electrons. How many electrons do I have? Let's check how many electrons would I need to add. Well, this is 0, no charge. This is 0, no charge. It's a compound, no charge, no charge. Overall charge of a compound is 0. Overall charge of a compound is 0. You only have plus 2 hydrogen ions, right? So here the overall charge is plus 2. Here the overall charge is 0. How do you go from plus 2 to 0? By adding 2 electrons on the more positive side. That's it. Is that why we studied acidified dichromate in O levels when we did oxidizing and reducing agents? Yes, Yomna. Yes, 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 yes. That's what I said at the start even. Next question. I'll continue to do this until and unless your concepts are clear. Yeah? Next stuff. Where are these electrons coming from? This is a half equation, Yahya. Where are these electrons coming from? This is a half equation. What's the second half equation for it? Here you go. I'm just making you guys write the half equation. The second half equation is this. So where would these electrons come from? They are coming from this fella right here. How? You balance it out on your own. Balance it out on your own. Tell me what the... Balance it out on your own. Come on, shaba, shaba, shaba. Balance it. Shaba, shaba, shaba. Balance, 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 balance. Shaba, shaba, shaba. Balance it, you'll figure it out. Shaba, balance this. It's complex ion. See, this is a complex ion. How do you balance complex ions? Pretty simple. But please notice here, there's one technique that I've added here. See, here you have 4 O's. First step is to balance out all the atoms except for H's and O's. So O's are here. I'm not going to cater to that. S and S already balanced. Great stuff. Next step, balance out the O's with H2O on the more deficient side. Here you have 4 O's. Here you have 2 O's. So in total, which side is deficient? The left side is deficient. How many H2Os do I add on the left hand side? Well, you had 4 here and 2 here. So I just need 2 more. I just need 2 more O's on the left. So I'll add 2 H2O on the left. Now some of you guys might think, sir, what if I say you have 2 O's here, so I add 2 H2O here, and what if you say you have 4 O's here, so I add 4 H2O here. In totality, this 2 will cut and you're going to be left out with 2 H2O again, right? So that's why it's up to you what you want to do, right? Yeah. So rather than doing it like this, you could say, hey, just take the difference. You have 2 oxygen deficients here. So add H2Os to balance the deficient side. Do it, do it, do it. Shabash. Let's do it. Balance out all the atoms except for H's and O's. I've done that. S and S, they're already balanced. Next step, balance out the H2O, balance out the O's with H2O on the more deficient side. So here you have 2 O's and here you have 4 O's. So you lack 2 oxygens here. What am I going to do? Step by step. Add how many H2Os here? 2 H2Os. Done. Now balance out the hydrogens with hydrogen ions. You have 2 times 2, 4 H's here. So add 4 hydrogen ions here. Now, where are the electrons going to go? Well, here you have overall charge of 0. They're all compounds, no charge, right? Here you have -2, and this is 4 times plus. 4 times plus is plus 4, right? So -2 plus 4 is plus 2. Now, how do I make 0 equal to plus 2? Add electrons on the more positive side. So plus 2 plus 2 electrons give me 0, right? So I'm going to add 2 electrons here. These 2 electrons which are lost are going to be gained by this bromine right here. Yes, you can write the full equation for it even. If I want, you can write the full equation. Now electrons lost and gained are equal. Cut. You get Br2 plus 2 H's plus SO2 plus 2 H2O gives me 2 HBr plus, I'm just adding the left and right, plus SO4 2 minus plus 4H plus. And you'll see something. You have 2 hydrogen ions on the left and you have 4 on the right. So you can cancel this out and end up with 2 H pluses. That's it. So this is the full balanced equation. Br2 plus SO2 plus 2H2O gives you 2 HBr plus SO4 2 minus plus 2H plus. Right? Why not 4? Because there you have 2 and here. The thing that's same on left and right, you could cut them out. Just like I told you, if you wrote 4 H2O here and 2 H2O here, at the end you would be left out with 2 H2O on the left. That's it. It's just balancing. That's how you balance redox reactions. Right? You want me to give you like 2-3 more examples? So to solidify this concept? Yeah? Do you want me to give you 2-3 more examples to solidify this concept, and then we'll be done. And then I'll also teach you basic conditions, because that'll help you out a lot in chapter number 4. I promise that'll help you out a lot in chapter 4. Although basic conditions are not in your course, let me tell you. But for now, let's just stick to acidic conditions. VO2 plus goes into V3 plus. Balance it out, sir. Again, complex ion right here. How do you balance complex ion? Complex ions normally have O's. Sulfate, phosphate, carbonate, manganate, chromate, dichromate, all of these ions. Chlorate, iodate, all these eights. Yeah. Chlorate 3, chlorate 5, chlorate 7. Shabash, do it. Question number 1, do this. You guys should be cheetahs in this. First step, always balance out the atoms except for H's and O's. Next. I2 goes into, now you guys shouldn't ask me where are the electrons coming from. It's coming from another half equation, right? And what is that half equation? We are not concerned with it. I just want you guys to balance these stuff out. Now you know where the electrons come and go. MnO4 minus. Potassium manganate, remember? Purple to colorless. This is that fella. So dichromate basically goes from Cr2O7 2 minus to chromium ion, which is 3 plus, and manganate goes from MnO4 minus to manganese ion, which is 2 plus. This is very common. You will see manganate going into Mg2 plus and dichromate going into Cr3 plus. That's it. This is also an oxidizing agent. Goes from, what is it here? Goes from +7 to +2. I believe it's +7 here. Yeah? -8 goes there. Yes, +2, +7. So +7 to +2 has been reduced, therefore oxidizes something else. So it's an oxidizing agent. Dichromate is reduced, goes from +6 to +3, therefore oxidizes something else. So these two are the most common out of them all. Let's do these 3 examples and then I will give you exam questions. Exam questions over and over and over again. These are all past paper questions. All past paper questions. All past papers. I'm adding nothing on my own. Yeah? Okay. I've given you enough time. Let's do it. First step. Balance out all the atoms except for H's and O's. V and V already balanced. Next step. Add H2O's to balance the O's on the more deficient side. So, let me write this again. VO2, let me change the color of this. Let's use white. VO2 plus goes into V3 plus, right? So the atoms are all balanced now, except for H's and O's. To balance this O, I need to add H2O on the more deficient side. Done. To balance this to balance the hydrogens in H2O, I need to add the hydrogen ions on the deficient side. Done. Now balance out the charges. Here you have 2 plus and 2 into plus. It's 2 plus. So in total you have +4 here and you only have +3 here. So add electrons on the more positive side. Done. That's it. Make it easy, huh? Make it easy, make it easy. Come on, ladies, come on, ladies. 1 pound fish. Come on, ladies, come on, ladies. 1 pound, 1 pound, come on, ladies. Where is this electron coming from? From another half equation. Actually, in fact, this half equation. I knew it, that's why I wrote this here. Okay, khair. First step, balance out all the atoms except for the H's and O's. Yes, 2 I's here and you need 2 I's here as well. Great. Now, to balance out the O's, 2 times 1. To balance out these 2 O's, add H2O on the more deficient side. So 2 H2O's. 2 O's, 2 H2O's. Great stuff. Next, to balance out these hydrogens, I need to add hydrogen ions. 2 times 2, that's 4. So 4H plus. Done. Next, 4H plus, everything is done. Write the electrons. Here, overall charge is 0. And here, 2 times minus, that's -2. And 4 times plus, that's +4. That does not mean that the oxidation state of I is -2 or the oxidation state of hydrogen is plus. No. Just considering overall charges. Here is compounds, elements, no overall charge. Here is -2. 2 times minus, -2. 4 times plus, +4. What do you get? +2. So, +2. Add electrons to the more positive side, obviously. See, 0, how do you make it equal to +2? How do you make 0 equal to +2? Well, you add 2 electrons here. So +2 minus 2 gives you 0. Done. 0 equals 0. You could have done the unconventional way as well. But we are going to stick to convention. I've taught you guys how to do unconventionally. Sir, what do we do if we're given a compound that doesn't have oxygen in it? Did it right here, Yumna. Did right here. There was no oxygen. You just follow the steps. Balance out all the atoms for H's and O's. We balance this out. Then balance out O's with the more deficient side with H2O, right? There were no O's, so skip that step. Next, balance out the hydrogens. Yes, 2 hydrogens with 2 hydrogen ions, right? And then in the end, electrons. So I purposefully made you guys do this in order to not rote learn things, right? How much more, sir? जितना आप कहेंगे, मुझे तो आते हैं. I know my equations. जितना आप कहेंगे. Next, do this. शाबाश. Come on, ladies, 1 pound fish. This guy got really famous back in the day. He now has proper fish stores. Very, very good. 1 pound fish. So he used to sell fish in London. Very, very good. 1 pound fish. 6.5 point 1 pound fish. 1 pound. Come on, ladies. 1 pound fish. Come on, ladies. Do it. Shaba. I just need to do 2 more examples. That's it. बस खत्म. 2 और examples कर लेते हैं. इसके बाद that's it. Come on, ladies. Please, these are only for complex ions half equations. अब ये ना हर चीज में ये शुरू कर दें. नहीं, हर चीज में नहीं. Complex ion half equation. Come on, ladies. 1 pound fish. Come on, ladies. You want me to give you guys like proper मजे का सवाल? Proper मजे का सवाल? Shabash, do this. Shabash, I need to give you guys 2-3 more questions. चलो मैं लिख ही लेता हूँ. I like those 3 questions. Question number 1. These are all past paper questions. I make you guys solve all the past papers, all the different concepts of past papers in class, so that when you sit in the past paper questions, when we start doing past paper questions, you're already familiar with things. Acha. MnO4 minus goes into Mn2 plus by oxidizing iron 2 plus. Obviously, I'm not going to write it completely, but by oxidizing iron 2 plus. Where will iron 2 plus be oxidized? To iron 3 plus, obviously. Write the full balanced equation. 3 marks. Next. One more question. What else? What else can I think of? I'm thinking, okay, here. MnO4 minus goes to Mn2 plus by oxidizing tin. Tin is Sn. Sn2 plus to Sn4 plus. You didn't know this, so I told you. Write the full equation, full balanced equation, 3 marks. Next. I do all of them with you in this class, don't worry. Next. और क्या हो सकता है? और क्या हम कर सकते हैं? What else can I do? I'm thinking. Why is the recording still on? I should have paused the recording. Oh, re sajna. Tin reacts with HNO3, nitric acid, to give tin oxide, SNO2, and NO2, right? The full equation. These are the most, this type of difficulty will never be asked. I am preparing you guys for everything. Okay. Another question. I'll make it so difficult. This difficulty they will never come. Another question. बस last मेरे ज़हन में ये आया तो last. और 2 चलो 2 और मेरे ज़हन में आ रहे हैं. Zinc reacts with, I'm not even going to give you the formula, iodate iodate. I'm not going to give you the formula of iodate ion, but I'll tell you it's iodate 5. Iodate 5 ion to give like to give zinc 2 plus and I2. अब मेरे जहन शुरू हो गया काम करने. Sulfate 4. Sulfate 4, you know what it is. It's sulfite effectively. Sulfate 4. I'm not going to give you the formulas. Although the examiner will give you the formulas, I'm not. I want you to figure it out on your own. Reacts with chlorine to give sulfate 6. Oh, I've written the formula. No! Sulfate 6 and chloride ion. Done and dusted. बस ये काफ़ी है मेरे ख्याल से. This is enough. This is enough, I guess. Show you from the top. चलो जी, let's start one by one. I'll give you 2 minutes to try on your own, and then I'll start. I started the recording. Yes, now my turn to solve it. I gave you guys long enough. So MnO4 minus goes into Mn2 plus. You have 4 O's, so 4 H2O's. Done. Balance out. I'm not gonna say the entire rules, but you have 4 O's here, so balance out the O's with H2O's. Done. You have 4 times 2, 8 hydrogens on the left. Balance it out with H plus is done. Now here you have minus and 8 into plus is what? Plus 7. So you have plus 7 overall here and plus 2 overall here. How many electrons do I need? Plus 5 electrons. Done. Finished. Khatam. Tata. Bye bye. Ciao. Right? How did you do that? Pretty easy, huh? See, let's use a lightsaber. Lightsaber. Boo! MnO4 minus 4 O's. Balance out the O's with H2O's. 4 H2O's. Then you have 4 times 2, 8 hydrogens on the right. 8 H pluses. Balance out the hydrogens with H pluses. Done. On the deficient side. Then minus and 8 into plus. Plus 7 is the overall charge here. Plus 2 is the overall charge here. How do I make plus 7 equal to plus 2? Add electrons on the more positive side. I added 5 electrons here, so plus 7 minus 5 gives you plus 2. Done. Easy. Next. This is a good question. MnO4 minus goes into Mn2 plus by oxidizing Fe2 plus. See, you know that Fe2 plus, if that's oxidized, it's going to be oxidized to Fe3 plus. You know that. You know that. If you didn't, you should know this from O levels and IGCSE. Fe either is in plus 2 or plus 3, right? And MnO4, I've told you it goes into Mn2 plus. It always happens. So MnO4 minus goes into Mn2 plus. Now, you know that this is simple. You know, it's pretty simple. Fe2 plus goes into Fe3 plus. How? By losing an electron. Great stuff. And then Mn4 plus. Again, 4 O's on the left plus 4 H2O's. 4 times 2, 8 plus 8 H pluses. You have 7 plus charge here, plus 2 charge here. So, plus 5 electrons, because 7 को 2 में कैसे लेके जाऊं? By adding 5 electrons. Done. Now you know that here you have 5 electrons. Here it's 1. That's not possible. How can MnO4 minus gain 5 electrons if only 1 electron is lost? So therefore electrons lost must be equal to electron gain, times it by 5. Now let's write the full equation for it. So it's 5 Fe2 plus Mn, add the left and right hand side. So MnO4 minus plus 8 H plus gives me 5 Fe3 plus Mn 2 plus 4 H2O. Done. What have I done? I've just added this to this. Ignore electrons because electrons gain and losses are equal. And I've added this to this. After obviously multiplying it by 5. Yeah? Easy peasy lemon squeezy. Next. I'm opening your brains. The examiner will give you a lot more detail than I am giving you. Examiner will give you a lot more detail than I am giving you. Next. MnO4 minus goes to Mn2 plus by oxidizing Sn2 plus to Sn4 plus. So Sn2 plus goes into Sn4 plus. You did not know where tin goes, therefore I gave it to you. But in iron, I know that you should know by now that iron 2 plus goes into iron 3 plus. I know that you also did not know Sn2 plus, which is tin iron, goes into Sn4 plus. You didn't know that, I gave it to you. Then MnO4 minus goes into Mn2 plus. Done. This is how you need to balance it out. What's the full ionic equation? Balanced. Well, first of all, this 2 plus is going into 4 plus. How? By losing 2 electrons. Great. And again, balance this out. You have 4 O's add H2Os on the deficient side. And please, before you check out the O's, check out the atoms. All the other atoms are balanced. Yes, Mn and Mn balanced. Then 4 H2Os. And if you don't do that, your answer will be incorrect. Then 4 times 2, 8. So 8 H pluses. And plus 7 plus 2 plus 5 electrons. See, now slowly and gradually you should realize that it's the same. Now again, here you have 2 electrons, here you have 5. How do I balance this, sir? Please understand that balance the electrons by taking this 2 multiplying here, but taking the 5 multiplying here. You could take LCM as well. So 5, it's effectively I'm taking LCM, 5 and 2. Why? That the electrons gained and lost must be equal. I'm multiplying this by 2 to get 10, and I'm multiplying this 2 by 5. Whatever is written here multiplied there, whatever is written here multiplied here. Why? Because I need to balance the electrons. Electron lost must be equal to electrons gained. Lost must be equal to gain. 2 is not equal to 5. How do I make them equal? By taking the LCM, which is 10. So, or you could say, just say take 5 multiply there, take 2 multiply here. So this will 5 times 2 become 10, 2 times 5 become 10. Right? Now just add the left and right hand side. So you have 5 SN 2 plus 2 MnO4 minus plus 16 H plus is on the left, gives you 5 times SN4 plus is 5 SN4 plus 2 Mn2 plus 8 H2O. That's the full balanced equation. And you know what the examiner is going to do? The examiner will not give you this stuff. The examiner will say, write the full equation. So डरना नहीं है, घबराना नहीं है. The examiner will give you this blank, this blank, this blank, this blank, this blank, and this blank. So it's much easier than what I am doing. I am making you guys make it completely. The examiner will give you blanks. What will you do? You will make it. You'll say, hey, 10 is simple. So 10 2 plus goes into 10 4 plus. Great stuff. You'll write this right like so. And then, you know, MnO4 minus goes into Mn2 plus. And because it's complex, this H plus and this H2O will be because of this. So just write MnO4 minus goes into Mn2 plus. And then you solve it and you're going to end up with this beauty right here. You know, this is 5. Let's complete it here again. This is 2. That's 16. This is how many SN? That's 5. This is 2. And this is 2 times 4. That's 8. Easy, guys. Pretty easy. SN reacts with HNO3 to give SNO2 and NO2. Okay. SN reacts with HNO3 to give you SNO2 plus NO2. Again, now balancing is very difficult for me. How do I do that? Split it. SN goes into SNO2. Great. HNO3 goes into NO2. So SN goes into SNO2 and HNO3 goes into NO2. Right? How do I do that? You guys, shabash. Aapne kiya hai ye ki nahi? Have you guys done this or no? Come on, I hope you guys can do this, yeah? Pretty simple. O's here, first of all, balance out all the other atoms except for H's and O's. So, SN balanced, great. Then look at the O's, 2 O's on the left. So, balance it out by adding 2 H2Os. Then balance out O's with H2Os. Balance out H's with hydrogen ions. So, 4 H's. So 4 hydrogen ions. What's the charge? So here you have no charge. Oh, sorry. Here you have no hydrogen ions. Here you have, let me change from the cyber stuff. How do I go from the cyber back? Yes. So here you have no charge. Here you have 4 hydrogen ions. So 4 plus, and this is 0. So how do I make 4 plus equal to 0? By adding 4 electrons. Done. Next. HNO3 goes into NO2. So first of all, balance out all the atoms except for H's and O's. So N and N balanced out. Then balance out the O's with H2O. Now please understand, here you have 3 O's, here you have 2 O's. How many on the deficient side, right? So 3 and 2. So I need to just add one more H2. I just need one more O here. So how do I balance one more O? By adding one H2O right here. And it's up to you. If you wanted to do it, it would just be hectic. To balance this 3, add 3 H2Os here. To balance this 2, add 2 H2Os here. So 2 and 3 will cut, and in the end you're gonna be left with one H2O. So that's up to you. Again, balance out the hydrogens with H pluses. Now see, here you have 1 hydrogen, here you have 2 hydrogens. So where is the deficient side? The left side. So 2 here, 1 here. So you just need 1 more hydrogen here. So I'm just going to add a hydrogen. It's up to you. If you said, hey, you have 1 H here, so add 1 H plus here. You have 2 H's here, so add 2 H plus here. The 1 H plus and the 2 H plus would cancel. You'll just be left with 1 H plus. It's up to you. It's simple math, right? So everything balanced. Now look at the charges. You have 0, 0, 0 and 1 plus charge here. So how do you make 1 plus equal to 0? That's adding 1 electron. Then then please, whenever you write electrons, if you don't write this negative charge on it, you're not going to get the mark. These are the small tiny details which the examiner will not tell you and still deduct marks. Now just add these two together. How do I add these two? How do I add the left and right hand side? By making electrons equal. So electrons lost must be equal to electrons gained, right? So multiplied by 4. When I add these two, let me see if I can pull this stuff down. Okay, I can absolutely do that. So what am I going to get? 2H2O plus Sn plus, this is 4. So plus 4H pluses plus 4HNO3 gives me SNO2 plus 4H pluses plus 4 times NO2 is 4NO2 plus how many H2Os? 4 H2Os. And we know that the 4H plus and the 4H plus, if there are still certain things which are similar on the left and right, they're going to cancel. 2H2O cancels out with 4H2O. You end up with 2H2O only, right? So that's it. That's it. So what do we get? Sn plus 4HNO3 gives me SNO2 plus 4NO2 plus 2H2O. Everything balanced. Everything balanced. That's the equation for it. Kitna simple. Kitna simple. So simple. Next. Do this. Shabash. Shabash. Now your morale should be up now. But last 2 questions, that's it. Acha, fun fact, in the exam, unless and until we are asked, we are never going to do this. This you needed to know, it's part of your syllabus. The examiner will ask you this for 2 to 3 marks. You know? But if it's not asked, you can still balance this entire reaction in like under 10 seconds. You know, with the help of oxidation numbers. And that's for tomorrow. So I will do the same examples. I will take these same examples and make you do it through oxidation numbers. Now it's up to you whether you want to do it like this or through oxidation numbers. Oxidation numbers, 10 seconds max. I already knew that this was going to come. I already know either 4 aana tha, and you know, that's why I knew this is correct. You know. So this is the donkey work method. But that's the true method. The reality is this. Come on, shabash, 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 shabash. Hey. Zinc reacts with iodate ion to give zinc 2 plus and I2. Right? So zinc reacts with iodate 5 ion. Iodate, remember chlorate was ClO minus. So iodate would be IO minus, right? But it's iodate 5 ion, which means iodate should have a charge of plus 5. So how many oxygens should it have? Well, plus 5 is iodate. Oxygen is minus 2, but I don't know how many O's I have, so times it by X. Overall charge is minus 1. So minus 2x, minus 1, minus 5. Minus 2x equals minus 6. X equals plus 3. So it's not plus 3 effectively. X equals 3, right? Minus minus cuts equals plus 3. So iodate 5 is basically IO3 minus. See, even if you forget the formula for it, it's not rote learning. Nothing is rote learning. Isme kya rote learning tha? It's literally the derivation of how I know that this is iodate 5. So you don't need to remember stuff. Okay? Iodate 5 is IO3 minus. You will be able to derive it so many times that you'll for yourself you'll remember it. I know chlorate is ClO3 minus. I know chlorate 5 effectively. I know chlorate 3 is going to be what? What would be chlorate 3? This is what? What is this? See, this is chlorate 1. Because see, if you want to check out how many O's it has, ClO minus, it is minus 2. This is X. I don't know X. This is minus 2. Minus 2 equals, this is overall is minus 1. So minus 2 shifts on the right hand side gives you plus 1. So this is Cl has an oxidation number of plus 1. Therefore, this is chlorate 1. And so this is chlorate 1. ClO3 minus would be chlorate 5. What would be chlorate 3? You know, chlorate 3. You could do all of that on your own, right? Khair. ClO2 obviously. Great. So chlorate 3 would be ClO2. You could calculate it even. Okay, khair. So zinc plus the iodate ion, IO3 minus ion, goes into zinc 2 plus I2. Next. Half equations. So zinc goes into zinc 2 plus, iodate goes into I2 minus. So zinc goes into zinc 2 plus. If there were any hydrogens or H2O, it would be because of this. So I would just consider this fella. Iodate goes into I2. What do we do, sir? Zinc goes into zinc 2 plus by losing 2 electrons. Simple. Iodate 3. First of all, balance. See, this was the mistake I was going to make. First of all, balance all the atoms except for O's and H's. So you have 2 I's here and 1 I here. So you have to balance this out. Now, 2 times 3, you have 6 O's. Please, you don't have 3 O's now, you have 6 O's. So for 6 O's, I need 6 H2O. For 6 times 2, 12 hydrogens. For 12 hydrogens, I need 12 hydrogen ions. What's the overall charge? This is plus 11, plus 10. 2 times minus is minus 2, plus 12. Minus 2 plus 12 is plus 10. Here you have 0. So how do you make plus 10 equal to 0? How do you make plus 10 equal to 0? By adding 10 electrons right here. So how do you balance out this equation? Well, here you have 10 electrons, here you only have 2 electrons. So multiply this by 5. Pretty simple, huh? And then just add them. So this is 5 zinc plus 2iO3 minus plus 12 H pluses gives me 5 zinc 2 plus I2 plus 6H2O. See, so many complex equations and you guys are able to now balance it. How easy. If the examiner were ever to give you this stuff, this 2 unknown, this 5 unknown, what would you do? What would you do if this 2 and 5 were unknown? What would you do? You would just take the zinc, go into zinc 2 plus, just like so. You'd break it. And the IO3 minus into I2. Why not take the H pluses and H2O? Why not take the 2s and the 5? So these will be unknown, but why not take the H pluses and H2O? Because you know that these H pluses and H2O are going to come as a result of this complex ion balancing. Done? So there will be 2I2. 2I2? No, it's just I2. Why 2? I'm not multiplying this with anything. This would be 2. Where would be 2I2? I've already done it. This is 2 I's and I multiplied this with 2. Why 2I2? That's the question. Why? Why are you adding 2 here? This was 2. I just need to balance all the atoms except for H's and O's. So this was 2 and this was 1. So I added 2 here. Why did you multiply this with 2? Okay, if you want to do that, it's up to you. If you want to stick with these things, you could do this. देखिए, हाँ, आप ये कर सकते हैं. आप ये काम कर सकते हैं कि ये 2 है, तो multiply this entire thing with 2. And अगर ये 10 है, तो multiply this entire thing with 10. If you want to do this, see 2 1s or 2 5s, you would still get the same thing. But if you want to do it like this, you can do it like this. But then in the end, everything will still cancel out. You would still divide everything by 2. Yeah. So instead of doing hard work, you just need to multiply. You just need to make the electrons equal. How can 10 be equal to 2? 2 times 5. That's it. Yeah. And if you multiply this if you just stick to this thing, this is 10. So I'll add 10 here. I multiply this with 10 and I multiply this with 2. So 2 1s are 2, 2 5s are 10. Or if you still don't do that, in the end, you'll see that all can be divided by 2. If you multiply this with 2 and this with 5, that doesn't make sense. If this is multiplied with 2, that gives you 20 and then this gives you 10. Right? So now you get it. Sulfate 4 reacts with last question. These are the most difficult examples ever. मैंने जो है ये examples बहुत मुश्किल से सोची है ताकि आप लोगों को full confuse कर सकूं. लेकिन I hope none of you guys are getting confused. I will do the same examples tomorrow. Examples tomorrow. But with the easier method. It's all methods are easy, but with the quicker method. Not the easier, the quicker. Okay. Sulfate 4. So I know sulfate is SO and it must have a 2 minus charge. What is sulfate 4? Well, sulfate 4 means this is plus 4. Oxygen is minus 2. I don't know how many O's there are, but add them, you get minus 2. Plus 4 minus 2x equals minus 2. Minus 2x equals minus 6. X, this cancels and you get 3, which means you have 3 O's. See? So sulfate 4 is SO3 2 minus. If you ever forget, but your practice should be so much that sulfate 4 means SO3 2 minus. Chlorate 3 means ClO2 minus. Chlorate 5 means ClO3 minus. Chlorate 1 means ClO minus. Iodate 5 means IO3 minus. And if you want to ever cross check, you can do this. So I've never learned them. Never ever. I've always stuck to my concepts. Sulfate 6 is SO4 2 minus. See, you should know this. If you want to figure it out, this is plus 6. I wanted to know how many O's there are, but each O is minus 2 times it by X plus. अब ये exam में नहीं करना. Exam में obviously you should have practiced so much that It should be on your fingertips. But because I'm teaching after such a long time, it is still on my fingertips, but I can even prove it for you. SO42 minus. So my concepts since day one, when I was a little kid, about chemistry were crystal clear. And if your concepts are crystal clear, you can figure anything out. Anything out. Right, so now let's look at the question. It's saying sulfate 4, which is SO32 minus, reacts with chlorine to give you chloride ion and sulfate 6. So reacts with chlorine to give you chloride ion and sulfate 6. Break it down. Break, Sonora, shake your body life. Na, 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 na. Yes, come on. देखा एक ख्वाब तो ये सिलसिले हुए, दूर तक निगाह में है गुल खिले हुए. Today I did not use a lot of my energy because I was already very tired. Because when I love practicing. I love practice classes and practicing like this. Why do I love practice classes and practicing like this? Because why? Because I don't have to use a lot of energy. Sir, I will make your edits one day. बस ना आप तो ये levels में आ गए. Chalo, let's do this. First step. Let's first stick with this simple stuff. So 2 Cls, 2 chloride ions. How many electrons are gained in total? See, Cl went from Cl to Cl1 minus, means electrons are gained. So how many electrons? 2. And SO3 2 minus goes into what? SO4 2 minus. First of all, it's up to you. Now, if you want to do the donkey work, you have 3 O's here, add 3 H2O's, you have 4 O's here, add 4 H2O's. In the end, you'll just be left with 1 H2O here, right? So 4 here and 3 here, add H2O's on the more deficient side. H2O, done. Again, 2 H's here, no H's here, plus 2H plus. Remember, the first step is always to balance out the atoms. I already saw this. A lot of students skip this step and done. Dusted, gone. 0. So S and S, I already saw this. That's why I'm just quickly going over it. Next, charges. 2 minus and 2 plus. 2 minus and 2 plus. That's pretty interesting, isn't it? It's a little interesting here. Yes, little interesting. What's little interesting? What's a little interesting? Well, you see that this is minus 2 and this is minus 2, but here you have plus 2. So this is 0. Now, which one is the more positive side? You're seeing this for the first time. It's up to you. However you want to balance it, it's up to you. But it's interesting because for the first time, it's just minus 2 and 0 comparison. So 0 is more positive than minus 2, which a lot of students don't know. So if 0 is more positive than minus 2, what am I going to do? I'm going to add 2 electrons here to make it negative 2. Done. And so 2 electrons lost are equal to 2 electrons gained. Just add this and this. Or guys, the electrons cut. Cl2, they are not actually cut, they are gained and lost, but the reason why you cut them is because you don't show them on these sides. SO4 2 minus plus 2H plus. Guys, we are officially done, but I will teach you the easier balancing method. Although the easier balancing method, it's up to you whether you want to know it or not. This is the reality behind things, but I want to teach you the easier balancing method so that you guys can breeze through the MCQs. Now, ye mera dawa hai, this is my challenge, that the detail that I have covered in today's class, Redox is officially over. I will add one more lecture from O-Levels and IGCSE on your portal, how to name substances, right? Because a lot of students, I can feel that you guys still don't know what the difference between hydrogen sulfide is, sulfate is. So I will add the O-Level IGCSE video for you guys. But now you know iodate, chlorate, you know these ions now. Iodate, chlorate, and whatnot. So, mera challenge hai, this is my challenge to the entire world, not just in Pakistan, to the entire world, that the detail that I have covered, इतनी detail में आपको कोई नहीं पढ़ाएगा, ना कोई पढ़ाएगा, ना कोई पढ़ा सकता है, right? Allah बड़े बोल से बचाए. The reason why I'm saying this is that I've put in a lot of effort, coming to this position. If there is oxygen, then we will consider H plus ions, otherwise no. What do you mean, Adil? What do you mean? If there are no O's, then you just go to the next step. If there are H's, then balance the H's with the hydrogen ions. It's simple, pretty simple. Balance the O's with H2O's, balance the H's with hydrogen ions on the more efficient side. सर आपने फुल इक्वेशन में 2Cl माइनस नहीं लिखा. ओ माय बैड. थैंक यू यशा. 2Cl minus. Forgot to add this fella to this. But thank you यशा. खुश रहें. Got it, Adil? Great. Any questions, guys? Any questions? Inshallah, tomorrow I'll teach you the. Tomorrow करें कि आज ही कर लें? आज रात को करें? ताकि मैं आप लोगों से जान छूट जाए यार. मजाक कर रहा हूँ. चलो नहीं यार, आज मैं देखता हूँ कितना काम मेरा काम भी बहुत पेंडिंग है ना. तो लेट्स सी इफ आई हैव टाइम आई विल क्विकली डू इट. ठीक हो गया. सो